Good day everyone, welcome back to my virtual classroom. For today's video, I'm going to be discussing again the measures of variability. This is the continuation of the descriptive statistics that I previously discussed with you, the measures of central tendency. So, to proceed with our discussion today, so let us define first what is measure of variability. A measure of variability for a collection of data values is a number that is meant to convey the idea of spread for the data set. And the most commonly used measures of variability for sample data are we have the range, we have the interquartile range, the mean absolute deviation, we have the variance or standard deviation, and of course we have the coefficient of variation. So all of this will talk about the spread of the data set. Okay, that's why it is called measures of variability. So let's talk about range. So range is, of course, defined as the difference between the largest and the smallest values in a data set. Or if it is a given row of scores, this is the difference between the high score and the low score. Okay, so the range does not use the concept of deviations. It is affected by outliers, large or small values relative to the rest of the dataset, and does not utilize all the information in the dataset. Only the largest and the smallest value, of course, are being considered in finding the range. It is not a very useful measure of variation also. Okay, so let us find the range of the following sample values. This is very easy. So say for example, I have the raw data. So we have 9, 1014, 1997, 1001, 1002, 999, 995, 990. So compute for the range. As I've said a while ago, range is the difference between the high score and the low score. So what you need to do is to identify the high score, which is 1014, and of course the low score, which is 9. So therefore, the range is 1014 minus 9 is 1005. So that's very easy. Okay. Another measures of variability is the mean absolute deviation, or MAD. Okay, the mean absolute deviation is the average of the absolute deviation values from the mean. This utilizes deviations of the data values from the mean in its computation. So we have the general formula for the mean absolute deviation. This is equal to the summation of the absolute value of x minus x bar. X represents the score and x bar represents the mean. Again, x bar is the mean. So score minus mean, okay, divided by the total number of observation. So that is the mean absolute deviation. So say for example, we are given several raw scores and we are about to find the mean absolute deviation. So first, you have to organize all your scores in a table. So it's easier for you to compute for the mean absolute deviation. Example, look at this. What is the mean absolute deviation for the following sample values if I have 3, 8, 6, 12, 0, negative 4, and 10? So the data set, so you just have to make a table, 2 column. So the data values, or this represents your x. So the score, so 3, 8, 6, 12, 0, negative 4, or 10. Okay? And of course, you have to get the absolute deviation. What is the absolute deviation? If we're going back to the formula, it is x, the absolute value of x minus x bar. Okay? X minus x bar, or x minus mean, because x bar means the mean. Okay. In this particular uh, set of values, you have to find first the mean. What is the mean of this data set? Okay, what is the mean of this data set? So getting the mean of the data set, so what you need to do is to subtract the mean from the what? From the scores. Okay? So, if you are going to look at it, the mean of this scores is 5. Okay? So, the mean of this scores is 5. So, if we're going to subtract 3 minus 5 equals negative 2. Why is this positive? Because we are getting the absolute value. Okay? So, if we're going back to the formula, the summation of the absolute value of x minus x bar. So, when we speak of absolute value, regardless of the sign. So, finding the mean of this, which is 5, so we have 3 minus 5 is negative 2, get the absolute value is positive 2. So, definitely, all the deviations here will be positive. Okay? So, 8 minus 5 is 3, 6 minus 5 is 1, 12 minus 5 is 7, 0 minus 5 is negative 5, but still positive 5. Negative 4 minus 5 is negative 9, so it's positive 9 pa din. 10 minus 5 is 5. So definitely you have now your deviation. So what's next? So you are going to add this because according to the formula, summation of the absolute value of x minus x bar or x minus mean. So we have to add all of this. So adding all those using the formula, so that is 32. Okay? So going back, so 2 plus 3 is 5, 6 plus 7 is 13, 13 plus 5 is 18, 18 plus 9 is 27, 27 plus 5 is 32. So that's why we have 32. And divided by 7, where did we get 7? So going back, so we have 7 observations. So 1, 1, 2, 3, 4, 5, 6, 7. So that's why divided by 7. So the average absolute value or the absolute distance of the sample values from the mean is 4.57. That is the mean absolute deviation. So I hope it's clear with you and you are getting across. So next, the variance and the standard deviation. So the variance and standard deviation are the most common and useful measures of variability, specifically if you are measuring the ratio, okay, or the grades, for example. These two measures provide information about how the data vary about the mean. If the data are clustered around the mean, then the variance and standard deviation will somewhat be small. If, if there is a small variability when the data values are clustered about the mean. Okay, so how do we find the sample variance? Okay, the sample variance is s squared is equal to the summation of the quantity of x minus x bar. X represents the score, x bar represents the mean, and of course, n minus 1. The total number of observation minus 1. Okay, the formula says that you have to subtract the mean from each data value and you have to square the difference. So get first the difference of the score and the mean, then you have to square. Then you add the values and divide by the sample size minus 1. So do not let the formula frighten you because this is easier when you do it in table. Okay, so let's proceed. What is the variance for the following sample values? So say for example, I have 3, 8, 6, 14, 0, 11. So what's the first thing that you're going to do is to get the mean first of this one. Okay, so the mean is, or x bar is, 42 divided by 6 equals 7. So 3 plus 8 plus 6 plus 14, 0 plus 11 divided by 6. So we have 7 as the mean. So your 7 will be subtracted in each of the scores and then you have to square. Okay, here it is. So the table shows that you are to write all the scores. Okay, since we computed 7 as the mean, so we have to subtract 3 minus 7, 8 minus 7, 6 minus 7, 14 minus 7, 0 minus 7, 11 minus 7. So we have the difference here. Okay, so what we need to do is, so since the formula says that you are to square the difference, so you have to square this. Negative 4 squared is positive 16. 1, 1, 49, because 7 squared is 49. Negative 7 squared is 49 also. And then 4 squared is 16. So get the summation of this, the summation of the square deviation. So we have 132. So in this table, you can now substitute all the values doon sa formula. Okay, so the variance says that s squared is equal to summation of x minus x squared over n minus 1. As we compute on the table, so we have 132 divided by 6 minus 1 because there are 6 observations minus 1. So we have 5. So now the sample variance is by dividing 132 by 5. So the variance is 26.4. Okay, so I hope it's clear with you. Okay, what about the standard deviation? The standard deviation is that you just have to get the square root of the variance, okay, or the sample variance. Get the square root of the variance both sides. So we have a square root of this is s square root of 26.4, and then you'll get the standard deviation. So that's how easy. Okay, so to make this clear with you, sample standard deviation is approximately equal to the average distance of the observations from their mean. Okay, so that's why this is the formula for the sample standard deviation. If all of the observations have the same value, the sample standard deviation will be 0. So that is, there's no variability in the data set. The variance is influenced by outliers, okay, in the data set. And of course, number 4, the unit of the standard deviation is the same as that for the raw data. So it is preferable to use the standard deviation instead of the variance as a measure of variability. But as I will clarify this, you cannot compute for the standard deviation without computing first for the sample variance. Get first sample variance and then get the square root, and then you'll find out the standard deviation. So the standard deviation of these sample values, since we have already computed the variance a while ago, which is 26.4, so get the square root, so we have the standard deviation of 5.14. Okay? So now, what about the coefficient of variation? The coefficient of variation naman allows us to compare the variation of two or more different variables. The sample coefficient of variation is defined as sample standard deviation divided by the sample mean of the dataset. So usually the result is expressed as percentage because coefficient of variation is equal to S, or sample standard deviation, divided by the sample mean, okay, of the data. So if you have all the values for this, you just have to divide them, then times 100. That is already the coefficient of variation. Okay, so example 1. The mean number of parking tickets issued in a neighborhood over a 4-month period was 90, and the standard deviation was 5. The average revenue generated from the tickets was 5,400, and the standard deviation was 775. So compare the variation of the two variables. Again, the mean number of parking tickets issued in a neighborhood over a 4-month period was 90, and the standard deviation was 5. The average revenue generated from the tickets was 5,400, and the standard deviation was 775. So compare now the variation of the two variables. So to find the solution for this, So we have get first the CV of the ticket. So we have 5 over 90. So since the standard deviation is 5 and the mean is 90 times 100, so we have 5.56%. And the coefficient of variation naman for the revenues, so the standard deviation is 775 and we have 5,400 as the mean, so times 100, so we have 14.35%. So since the coefficient of variation is larger for the revenues, this is bigger, there is more variability in the recorded revenues than in the number of tickets issued. So that is how easy we find the coefficient of variation. So I hope you learned something today. If you do, congratulations. And if you think this is confusing, you can go back, you can replay the video for you to be able to understand the whole topic. So before I go, so I hope you've already subscribed to this channel. If not, please subscribe to this channel and thank you so much. See you on my next video. Bye.